doing top minus bottom, when you're doing an integral with respect to x, it looked like there might be some y integrals, so that's left minus right. Okay, so the integral is 1 minus, because this is your top function. I don't know, maybe you're using like f and g in class, but I like the words better. I think they mean more. And then your bottom function is this cosine squared x dx. And then from here, you need the bounds. You need the lower bound and the upper bound. They give it to you in this particular problem. You may be asked to actually set them equal and figure out that it's from 0 to pi for that. Okay. So how is your memory of trigonometry?
Well, it depends on what part of trigonometry.
Yeah, so I'm gonna send in the chat here a reference sheet that I keep handy. Trigonometry is very heavy on formulas, and the formulas here help us to kind of answer to do this integral. So my preference here is to use a double angle formula. I'll snip that in. Okay, and you might be thinking, well, how do I use that? Have you seen this before in class, or was this first time this has come up where you've needed a trig formula?
I've seen that a while ago. It's been a...
Okay. So the way the formula works is it's this middle one that you get. You have to use, and it comes, I call it 3 flavors here. You got, and we're going to use this one. We're going to solve that for cosine squared. So when you solve this one for cosine squared, you get cosine 2 theta plus 1, because you move that over, and then you divide by 2, and that equals cosine squared theta. And you can use x instead of theta. So all of this in the box here is going to replace this right here. Now you might think, well, hey, can I just call 1 minus cosine squared sine squared? I don't know if that occurred to you, because that's one of the trig identities. Yes, but you still end up using one of these formulas. So no real shortcut on that front. Is this okay? Or please tell me if we need to review this, because it's the important part of doing it. The rest is just finding an antiderivative from here on out. Is this okay?
Yeah.
For understanding? All right. So we get the integral 0 to pi 1 minus, and then I'm gonna just kind of slightly rewrite this, 1/2 cosine 2x, okay, and then plus 1/2 here dx. So again, just a little simplifying here. When you distribute the negative in there, you end up getting 1/2, 1 minus the 1/2, and then you get minus 1/2 cosine 2x. And we still haven't integrated yet. We're just simplifying here. So that becomes 1/2 x minus, now the antiderivative of cosine is sine. And you're supposed to make a u substitution, but we're kind of at the point of the course where maybe you're okay to do this without that. If you take the derivative of sine, you get cosine. If you take the derivative of 2x, you get a 2 out in front. But we're supposed to get 1/2, so that means you put 1/4 here. And if that's not clear, I'll write it over here off to the right. The derivative of this, going this way, derivative is cosine 2x times 2, and that equals 1/2 cosine 2x, which you can see is this part here, evaluated from 0 to pi. So we get 1/2 pi minus 1/4 sine 2 pi minus 1/2 times 0 minus 1/4 sine of 2 times 0. And sine of 2 pi on your unit circle, that's all the way back where you started. The y value there is 0. So this part is 0 because the sine is 0, or sine of 2 pi is 0 multiplied by 1/4. 1/2 is 0, 0. Sine of 0 is the same thing. So a lot of zeros. So just as 1/2 pi as your final on that one.
Okay.
is everything from kind of, I don't know, like right here where you actually do the intervals, like all of this really comfortable for you, finding antiderivatives, evaluating at the top and the bottom? Is that all good?
Yeah, I'd say so.
Okay. Okay, number 13. Number 13, where are we? 13, there we go. Generally, you don't get the graph, but it's really nice when they give it to you. So if they didn't give you the graph, that would be the first thing they would do is graph it. And so this one, they want the shaded area. There's really two regions. There's what I would call region 1 and then region 2.
Mhm.
And you're going to add them together. So it's literally region 1 plus region 2. Region 1's top function is this one that I'm tracing out here, which maybe isn't clear, but it's this one right here. Maybe I'll do it in a different color just to make it kind of, in case you look at the notes later here, but that's this one. And then the other one is in blue. Get my blue out. There's blue. So the top function on the left here is 2x cubed minus x squared minus 5x. That's your top. And then you subtract the bottom. The bottom is this minus x squared plus 3x. Okay, so it's always that top minus bottom. And then you're integrating this from the left endpoint to the right endpoint, and it's the x value. So they actually give you the x value here, which is nice, -2 to 0. Okay, and that's a dx. And that's just region 1.
Mhm.
Now, are you allowed to use a calculator, or do you have to show all your work for this?
I can use a calculator, but I still have to show my work.
Okay. So my like maybe I'll ask you differently. Like from here, it's distribute the negative, combine like terms, use the power rule. Like, do you have to write all that out, or can you just put this in the calculator and get a number?
I'd probably have to write it out.
Okay, well, we'll do that then. So 2x cubed minus x squared plus x squared, that's going to cancel. Minus 5x minus 3x is minus 8x. And so now you're going to find this, the antiderivative. So it's x to the 4th, but then this is going to be a 1/2 minus 4x squared. And you're valuing that from -2 to 0. Okay, and the nice part, I guess, is that 0 endpoint doesn't amount to anything. So it's 0 minus 0 minus, and then this is where you put the -2 in. So -2 to the 4th, that's 16, half of that's 8. This is 4, 16, so it's 8 minus 16, which is -8, but then there's a negative, so it's +8. And you should always get a positive area. So if you get a negative area, check your signs, check that you did the right top minus bottom. If you choose the wrong top and bottom and you do the math right, you do get a negative area, like if you were to switch the order of these. And so you can kind of like work around that in some problems, but it's always good to do it in the right order. So that's all region 1. That's only, half the problem here. We got to go to region 2. Region 2 is from 0 to 2, and it just switches the order here of the integration. So I'm kind of limited on my screen here, so I apologize if you can't see all that, but it's integral from 0 to 2, and your top function this time is the minus x squared plus 3x minus parentheses 2x cubed minus x squared minus 5x dx. So we got minus x squared plus 3x minus 2x cubed plus x squared plus 5x. So again, those x squareds cancel, and you get 8x minus 2x cubed. And it's the same antiderivative for the most part. It's 4x squared minus 1/2 x to the 4th. And you evaluate from 0 to 2. Is that right? Yeah, it's 0 to 2. Okay, so you get, this time you get 4 times 2 squared minus 1/2, 2 to the 4th minus, both of these are 0 when you evaluate them. So what is that? 16 minus 8 So another 8. So your total area is 8 plus 8, which is 16. Yeah. All right, let me go back to our chat and see what the next problem is. 17. Okay, 17. Done with the pictures. Do you normally get only odd problems for your homework?
I do get mostly odd problems.
Yeah. All right, so this one here, they want you, the instructions just say to find the area between the curves, okay? And you don't know where it is unless you could graph it. So if I get, like, I could actually have given you this problem in another class, just said solve, figure out where they equal, and you would just set them equal. And that is the first step here. So you would subtract 4 from both sides, 3, you'd add 2x squared to both sides. So you get 3 equals 3x squared. You'd solve for x and get plus or minus 1. You can, you really should graph these. Even if it's not like a really good graph, like this one on the left, it goes down, or it opens down, and this one opens up. So it's reasonable that there's only 2 places where they intersect. So you don't have to worry about like a third place like we saw in 13. There's just these 2 points. So these literally translate to -1 to 1 on the bounds of the integral. But if you got like 3 intersection points, then you got problems here. So sometimes students are like, well, how do I figure out which one's on the top, which one's on the bottom? So if you have a graph, that's great. But if you don't have a graph, you test a point between the bounds, like 0. So if x equals 0, let's see, let's snip this in here again. If x is 0, and the first problem, it becomes, or the first one here becomes y equals 7 minus 2 times 0 squared, which is 7. And the second one is y equals 0 squared plus 4, which is 4. Which one is bigger? This one on the left. So this tells you this is top, and then this is bottom. If you don't do that, and you could potentially get a negative area. So it's 7 minus 2x squared minus x squared plus 4 dx. So we get 7 minus 2x squared minus x squared minus 4. And then combine like terms here. So we got 3 minus 3x squared dx. So your antiderivative is 3x minus x cubed, evaluated from -1 to 1. 3 times 1 minus 1 cubed minus 3 times -1 minus -1 cubed. 3 minus 1 minus -3. -1, that becomes +1. It's really easy to mess up signs here. I mean, this is -2, and then change it to +2. That's 2, so it looks like it's 4 when you're all done.
Okay.
All right, so this section we're doing becomes much more important when you start dealing with volumes and discs and washers. Maybe you've seen those, or if not, they're upcoming. You end up doing this, finding the area, using the area between curves to answer the questions, how to find volumes of solids.
Yeah.
So this question here, this one's not as interesting because they already give you the bounds. They tell you your integral is going to be from -pi/3 to pi/3. Okay, great. And as I mentioned before, you got to figure out, well, where's the top and where's the bottom? Okay, so if we try x equals 0, I'm going to put x equals 0. This first one becomes y equals 8 cosine 0. Cosine of 0 is 1, so this is 8. And this one becomes y equals secant squared of 0, which is 1. Because secant squared is 1 over cosine squared. Cosine 0 is 1. 1 over 1 is 1. However, I'm going to graph this. I don't know. I just have a suspicion here that there might be another intersection point between the two. And that would totally change everything that we're doing here. So let me just really quickly graph this, and then I'll share that snip of what the graph looks like for you. I'm using Desmos. Do you use that at
Yeah.
all on your own? Okay. And one of the nice things about it is you can literally say, okay, I only want it from minus pi over 3 to pi over 3. And it really makes it a lot easier to graph here. So let me snip this in so you can see it. It's kind of a neat shape, I guess. This looks like, all right, so we got this. All right, so here we go. So there is, like, it truly is just the two endpoints.
Mhm.
But I guess I had a suspicion, well, what if they actually intersected another place? Like you can imagine a curve where, you know, they intersect more than once, and you gotta be careful there. So it's literally just top minus bottom. And so let me grab this, move it down here. So your top is, what did I say here? Cosine 8 cosine x minus secant squared x dx. All right, so time for you to jump in here a little bit. Do you remember the antiderivative of cosine?
The antiderivative of cosine is sine.
Sine x, perfect. How about antiderivative of secant squared?
It's tangent.
Yep. Okay, so not too difficult. You get 8 sine x minus tangent x minus pi over 3 to pi over 3. Now perhaps the harder part is evaluating at the endpoints. So this is where the instructor could say, hey, I told you, you got to remember your trigonometry. And this is what they really mean is your unit circle. So that cheat sheet I sent you has a unit circle on it. If if you ever want to look that up real quick, that's a good one to have printed out. There's obviously a million things online. So sine pi over 3 is square root 3 over 2. Tangent pi over 3 is sine over cosine. So it's square root of 3 over 2 over 1/2 minus 8. Now sine of minus pi over 3 is the negative of this one, because you can do some quadrant relationships over there, minus, and then tangent in that fourth quadrant is just negative of the first quadrant, so it's negative square root of 3 over 2 over 1/2. Just got some fun sign stuff here. So we got 4 square root 3 minus square root 3 minus, what we got in here, minus 4 square root 3 plus square root 3. So this inside here is minus 3 square root 3, but then it becomes positive, so it's plus 3 square root 3. This is 3 square root 3, so it becomes 6 square root 3 as your final answer on that one.
Okay.
Is this more or less interesting than last night doing the application problems?
I guess it's a little bit more interesting.
Okay. These maybe are more familiar to you also, which I think could help. All right, so what is the next one for us to look at here? Let me go back to my chat here. And you said 39. We're gonna find 39. Oh no, triangular region. Find the area of the triangular region in the first quadrant bounded on the left by the y-axis and on the right by the curves sine x and cosine x. So without doing like a real fancy graph here, we know that sine goes up like that, and cosine comes, it starts high and it goes down like that.
Mhm.
So there's this point where they intersect, and that is pi over 4. And I guess that's what it's referring to, this region right here. I don't know why they would call it a triangular region. I'm just graphing it here to like verify that I'm not losing it here. Yeah, I mean, that's what it is. I don't know. So it's still just a top minus bottom. Your top is cosine and your bottom is sine.
Mhm.
So it's cosine x minus sine x. Your limits are from 0 to pi over 4. Do you want to try doing the rest of this one on your own, please, and see what you come up with?
Yeah, I can do that.
All right, I'll stand by.
Okay.
All right. Is your final answer the square root of 2 minus 1?
Yep.
Okay, perfect. Would you like me to show you the workout for this one, or do you feel like you've got it?
I think I know how to do it.
Okay. All right, fantastic. So that's 39, 52. 52. So University of Arizona Calculus 2 class, they have the same class for all students almost all the time. And one of their most often asked questions is, to set up the integral, but not to actually calculate it.
Mhm.
So in this case, like I wouldn't actually look at the answers. Like I would like rather us, and I'm just going to do this here, is snip the just the question, and then we come back and like match our answer to the one that's given. So this one says, let R be the region in the first quadrant bounded by the x-axis and the graphs of x equals and x equals down here, x equals y squared plus 2 and x equals 4. So whenever it's solved for x, you know that it's going to be a y integral.
Mhm.
And that's, I mean, maybe you already know that, but that's kind of an important like starting point here. So I don't know if any of these are in terms of x, they're not, so that doesn't help. The next thing is to just set them equal, and 4 equals y squared plus 2, y squared equals 2. So y equals plus or minus square root of 2, but they want you to be bounded by the x-axis. So the x-axis is down here, obviously. So this y equals minus square root of 2 would be down here.
Mhm.
And that's not part of the problem. But the one up here where it's y equals positive square root of 2, that is.
Okay.
Okay. Now you probably took a pre-calculus class where you learned how to graph this. It's literally, you just switch x and y. So it would be y equals x squared plus 2. And you know that that graph looks like this. And then you just rotate it right 90 degrees. So it
Mhm.
ends up looking like this. So your graph that looks something like this. Okay, and then y equals 4, or I'm sorry, x equals 4 is there. So some, I know it's not to scale, but just roughly. So we're looking for something that probably that region right there. So the first thing I notice is the bounds are going to be from 0 to square root of 2.
Mhm.
So that gets rid of, gone, gone, gone. And then I mentioned this earlier, when you're doing y integrals, it's right minus left. And your right is this 4. So it's going to be 4 minus, what's the x, y squared plus 2? Yeah, y squared plus 2. So in terms of the answer, it's A.
Okay.
And if you wanted to, you could obviously integrate it and, go down all those steps, but just busy work at that point. So the more calculus you take, the more you just set up and then not actually do it because it takes too long in some cases. Truthfully, yeah. I mean, it just. All right. So if you got all that down, we do have some time if you would like to use it. Is there anything else you would like us to look at today?
Guess I could go to the next chapter.
All right. All right, give me just a moment here. I'm going to get just got sidetracked slightly. Okay, so 8.31379. Okay. Let's get there. Volumes. Have you done volumes, Natasha, already? Or is this totally new?
A little bit.
Okay. All right, there is number 1. Oh, great. So it's got multiple parts. All right. Okay, here's number 1. Is that what you're seeing as the first question to work on? If you said yes,
Yeah.
I didn't hear you. Okay, great. So the solid lies between, I don't really like this, but it lies between, really I think this will be easier to look at in the XY plane. There's a top part and there's a bottom part here. And this top one is the square root of 1 minus x squared. This bottom one is minus square root of 1 minus x squared. And they're saying that they're semicircles. The cross sections are semicircles. So it's like saying, okay, it's like this is the diameter of the semicircle. And they're I mean, that would be equivalent to like something here is what they're trying to show you.
Okay.
So the way that this works is you first find the area of the cross section. So the area of the cross section is is the semicircle. So the formula for semicircle is pi r squared divided by 2, but r in this case, r is top minus bottom. And then you also have to divide it by 2 because the whole thing's a diameter.
Mhm.
All right. So the like the way this works is it's a lot going on here. It's r becomes the square root of 1 minus x squared minus square root 1 minus x squared divided by 2. So it becomes 2 square root 1 minus x squared because you get 2 of them up top divided by 2. So it ends up being just the square root of 1 minus x squared. And that's your r. So your integral is this area, so this pi r squared, but your r is the square root of 1 minus x squared squared all over 2 dx. And then you go from -1 to 1.
Mhm.
Okay. So from here, it's just a matter of doing something you've always done, which is you know how to evaluate this. Like we don't even need the picture anymore, but the pi over 2 I'll bring out, integral -1 to 1. This part in here reduces to 1 minus x squared dx. So it becomes x minus 1/3 x cubed, evaluated from -1 to 1, and then pi over 2 times whatever that is. So that's pi over 2, 1 minus, and then 1 cubed is 1 times minus 1/3, and then minus 1. And then when you put -1 in here, it's -1, but that negates, it becomes plus 1/3. So this is 2/3, this is minus 2/3, but then it's plus, so it becomes 2/3 plus 2/3, 4/3. So it's pi over 2 times 4/3, which is 4 pi. Actually, it reduces to 2 pi over 3. That's just part A. A small point here, because I don't have the answers, is these don't actually look like semicircles. They look like full
Circle.
circles. And I don't know if that's a mistake, but oh, you know what? I'm sorry. It does say circular discs. Oops. Okay. So that changes this divided by 2. We don't need that anymore. But this r stays the same. It's just that divided by 2 isn't needed. And that 2 isn't needed. And that 2 isn't needed. Same with that 2. So it becomes 4 pi over 3. Sorry about that.
That's fine.
Did not pay attention. Okay, B will be more straightforward. So sometimes on exams, they actually ask you to draw the cross sections. And so you kind of got to show something coming out of the page, which could be a little bit tough if you're not good at drawing or not very, if you're not able to visualize it.
Mhm.
So that top one again is y equals square root x minus 1. The bottom one is y equals minus square root x minus 1. And the distance across, it's the same as before, but if it's square root of x minus 1 minus square root of x minus 1. So it's 2 square root x minus 1 is the distance across here. And this time the squares, the area of a square, as you know, is base times height. The base is 2 square root x minus 1. And then you multiply it by itself, or you could just square it, whichever one you like. So it becomes 4 parentheses x minus 1, or 4x minus 4. And the reason we need that is because that's what you're going to integrate. You always have to find the area function to integrate it and integrate that. So your volume is the integral from -1 to 1 of your area function 4x minus 4 dx.
Okay.
What is that? 2x squared minus 4x divided from -1 to 1. So that's 2 minus 4. That's not good. That's not good. Yeah, it's really not good. Okay, maybe there's a mistake here. 2 plus 4. Yeah, that's not good. Something's amiss here because you can't get a negative volume. Base times height, 4x minus 4. Just sorry, I'm just looking here. It's not coming, not obvious here. Top minus bottom. Base times height, so you square that, 4x minus 4. Do you happen to notice anything that's not right here? Because I'm not seeing it's a small sign error or something very significant, but it's causing problems here. Oh, I know. Okay, I see it here. I wrote the wrong function here. It's square root 1 minus x. Which that's what we did in the last one, but for some reason I didn't catch that. 1 minus x squared. So that's really bad. Okay. So it becomes 1 minus x squared in here. This is 1 minus x squared, 1 minus x squared. So it becomes 4 times 1 minus x squared. So all this stuff changes. So 4 minus 4x squared. That's what you're integrating. So let me clear out all this. 4 minus 4x squared. So that's 4x minus 4/3 x cubed from -1 to 1. So this one will work out a lot better. 4 minus 4/3 minus 4 plus 4/3. And so whenever you're mixing whole numbers and fractions, like this one becomes plus 4. This is minus 4/3 minus 4/3. So this is 8/3. This is 8, but we want 3 as a bottom. So go 24/3, and that becomes 16/3. And that does work.
Okay.
I know we got to do part C, but it would be good to move to other problems unless you really just want to do question 1, because like the more like 7 is potentially a more useful question to do, but totally up to you.
That's fine.
Okay. All right, so question 7 is what is called a disk problem. I saw on social media, an instructor actually called it a pancake was maybe a better example. So the reason is because the disks, when you revolve this thing around the x-axis, like you're taking this right here and you're revolving it around the axis, you get this big circular thing. And down here, it's much smaller. Okay, so the pancake is kind of an interesting analogy because sometimes you get small pancakes, big pancakes, but the like official name is the disk, which maybe you'll hear in class. I'm not sure. So
Yeah.
the disk method is when there is no gap or no break between the axis that you're revolving around. So I like to actually show which axis I'm revolving around to like make it really clear. But if there's no gap, that's a disk problem. So no gap or no break. Because a lot of times you'll get where you've been shown a couple of methods like, hey, which one do I use? And that's how you know. Now they've been kind enough to kind of draw this in here for you. This is your radius. And more generally, it's the integral from a to b pi r squared dx. And r is a function of x. R is really like your y. So you have to solve this for y. So y equals 2 minus x divided by 2, or we can write it as 1 minus 1/2 x. That is your r of x. And your radius changes. That's what I was trying to explain here. Your radius goes from being really big to being really small. And that's what you have to find. That's the key here, because you're going to end up squaring it. So for this problem, you're going from 0 to 2 along the x-axis here. Better to move that pi on the outside. And then it's 1 minus 1/2 x squared dx.
Yep.
So to integrate this, you really should expand the binomial first. So that's 1. And then, if you do your outer and inner, or if you want to use your formula for this, it doesn't really matter. You just got to get the right combination of things here. So you're integrating this function here, dx. It's really not difficult. It's just a lot of work. It's just a lot of, you're no longer just being asked to do one antiderivative here. The nice thing is when you evaluate at 0, everything clears. So you just have to evaluate at the top endpoint. 2 minus 1/2, 2 squared, plus 1 over 12, 2 cubed. So what is that? 2. So those are going to cancel. 2 cubed is 8. 8 over 12 is 2/3. So it looks like it's 2/3 pi for your answer on that one.
Okay.
Sometimes they ask you, like, what does this look like when you revolve it around the axis? And this actually looks like a cone. You can maybe visualize that. If not, that's okay too. All right, so 13, kind of boring. Let's see what 39 looks like. See if we can find some more interesting here. That's kind of like the earlier ones. 65. Don't like that. Okay, we'll just do 13. I was hoping we might get something else, but so the next question here. So the graph of this square root 9 minus x squared, whenever you get a square root of number minus x squared, it's almost always a semicircle. And that's helpful. Like, it's helpful to be like, okay, what does this thing look like? Well, it's 3, 3, minus 3 and 3, like it's this right here. And there's this graph here. And so again, just in some color, sometimes it's good to show what the actual radius is. That's your radius. And your radius is usually a function of x, or in this case, y. So they just give it to you. Like, there's not really much work to do when they give this to you. So you got to find your bounds, because it's the integral from a to b pi r squared dx. And so your bounds, left bound, right bound, and you're revolving around the x-axis. I think it said that in the problem instructions. Let me go look. Yeah, just about the x-axis, because you could actually revolve around the y-axis too, but it's good to kind of indicate which one you're revolving around. So this is the integral from -3 to 3 pi, and then your r in this case is square root 9 minus x squared dx. Okay. So good to square this, becomes 9 minus x squared, and then you're just left to integrating these these things. 9x minus 1/3 x cubed. And you value it from -3 to 3. You might at some point start noticing some patterns. This is an odd function. And so you might start noticing some things here. And same thing with even functions. We don't have enough time to really like dive into that, but it just, if you do a bunch of these, you start seeing stuff like that. So it's 9 times 3 minus 1/3 times 3 cubed. Because that's 27 minus 9. I guess that's okay. Minus 9 times -3 minus, so that's negative 27, but that's negative, so it becomes plus 9. So you have minus 27 plus 9. And so this is minus 18, but then it's plus, so it's plus 18. This is 18. So you get 36 pi.
Okay.
All right, so pretty intense session today on the math here. If you followed everything, if you understood it, you're doing great. But thanks so much for letting me help you. I will send you the notes out shortly, and I'll see you next time.
Thank you.
Have a great night. Bye now.
You too.